Good afternoon, ladies and gentlemen. Today we have got the honor to invite distinguished professor, fellow Vivian Chen to do our standing forum for innovative to impact applying carbon dioxide concrete in real world construction. So before Professor Tan can continue his fantastic presentation, I'll just briefly introduce our journal on behalf of our committee. So our journal is Building Design and Environment. Our target impact factor is around 7, and we have established from August 2023. And we launch 3 issues every year. So there will be no, although we are open source journal, but there will be no APC phase before 2029. And these are the WeChat links between our journal website as well as our linking. So far, currently, Professor John Kang from University of College London, they have taken the chair of the honorary editor-in-chief. And also we have 2 editors-in-chief, Professor Li Mao Zhang from Huazhong University of Science and Technology, China, and fellow Xiangyu Wang from East China Jiaotong University. And I myself from Curtin University take charge of the executive chief editor. So our journal have a broad scope of the aims, such as intelligence construction, smart building systems, advanced building materials, composite materials, structural design, and such on. So far we have got more than 30 additional board, all distinguished professors and young researchers from all over the world join our big party. And China and Australia take the majority of all the editors. And besides, more than 40 young editors also stand our band. And so far we have invited more than 50 young members to donate their contribution to our journal. And we still recruit these outstanding and interesting young researchers to our journal. And our criterion is under 45 years ago, a PhD holder, as well as some scholars specializing in agricultural design and building environmental research. And as for the benefit, we can receive official certificate of appointment, as well as some publication policy, which is benefit to you. And so far, the journal is in cooperation with the 11th International Conference on Innovative Production and Construction. And we have got around 10 papers in reservation to contribute to the special issue for the JBDE journal. Okay, let's step into the most exciting part. And let me have the honor to introduce our guest, Professor Vivian Tim. She's a distinguished professor is a fellow of the Australian Academy of Technological Science and Engineering. She's a world-leading researcher in the field of construction engineering and management. She's currently the director of the ARC Industrial Transformation Trading Center in digital platforms for net zero building its ecosystem lifestyle. She also is the director of the Center for Infrastructure Engineering. She's also the associate dean at the School of Engineering, Design and Built Environment, Western Sydney University in Australia. Professor Tan has served as the College of Expert Australian Research Council, Australian government in 2018 to 2021, and currently holds his position again from 2024 onward. She's also nominated as the runner-up Scopus Researcher of the Year Award in 2019, Excellence in Research Impacting a Sustainable Future Scopus. Okay, let's welcome our professor to give up the outstanding speech.
Thank you. Thanks very much. Yeah. Okay, thanks very much for the introduction. Let me share my screen. I think you can see the presentation mode now.
Sure.
Yep. Okay, that's good. Yeah, thanks very much. Today I want to talk a little bit of my experience about the recycling concrete, particularly on my recent inventions on CO₂ concrete as well. Already really have a great introduction by Jimbo, but I would like to introduce myself a little bit more on the background. My research interest was starting in sustainable constructions. And in the management components, I'm also looking into the green buildings and also life cycle analysis. But today I want to present a little bit of the research about my technological research on the recycled concrete. I'm currently the editor-in-chief of International Journal of Construction Management. Some other information about the competitive research grants, research publications, and research impact I leave it for you in here. I always have an idea of turning waste into resources. Since I was an undergraduate student, I was studying research on environmental management, particular focus on waste management as well. Leading to the when I was leading to the PhD, actually moving the waste management become waste recycling a little bit more, particularly on the recycling concrete components. And all of those, I'm also looking into the life cycle analysis. But overall, I'll classify myself research on the sustainable construction management and engineering. You may see in here that what is really the driving force for sustainable construction, since it is my major research area. Some people will look into the climate change, or some are looking into protecting the environment, particularly in this perspective. But I think it's also very important to looking into why the public need to do it, what's the awareness need to do it. Do they have any financial incentive or financial benefits? Not only about maybe the instant benefit, like the short term, but also looking into long-term components as well. And a lot of research also like to look into the energy efficiencies. How can the energy be able to even help reducing the cost in this component? There are three major trends that I can see when we are doing the sustainable building or sustainability constructions in here. The first one I want to highlight is the growing focus on the healthy building materials. Building materials could be the recycling materials or could be some other reusable materials. But the terminology of the healthy, which is also looking into the long-term component as well. That means not only about that you can reuse it again, but also how can you continuously helping that in terms of that healthy, productive environment in terms of the long-term component. Another one is the embodied carbon. Emphasize on the embodied carbon. That means because of the net zero component is looking into so important. A lot of us are looking into how can we achieving the zero target, carbon zero target. And all of those is looking into how can we really improving those embodied carbon consideration as well. And I have to say that we have to look into technologies if you want to look at those. By purely adopting the materials or by purely reusing or recycling may not be able to achieve of what we want to work, particularly for the building industry. That's why the technologies adoptions is relatively important on looking into how can we embed it in that with that sustainability building component in here. Based on the Australian data, we have roughly about 29 million tons of construction and demolition waste every year. And we have recycled about 22.5 million tons, which is relatively high. But the thing is, we are not able to reusing as a high-grade component. Most of them are still mainly using it for low-grade recyclability options. That means when we want to use the materials for a replacement of virgin materials, it will have difficulties to use it. That is what the existing market look like. Looking into construction and demolition waste recycling, a lot of people also like to see a four-steps approach. Different people using different terminologies, but their approach is very similar. First of all, obviously, we try to prevent producing the waste. We try to not even generating the waste to doing the waste management component. But if we have to generate the waste, because some of the activities on site, you cannot just, like say, for example, order the right amount. You have to order a little bit of extra in case anything happens. And that means we will have to generate the waste. If we have to generate the waste, do we have any approach that we can actually separate the different type of waste? Because most waste are generated mixed together, which is also very difficult for us to be able to further reusing or recycling that as well. There's a separation is the second options. And then the third level of waste recycling is the treatment. Once we do the different kind of waste sorting, we will need to look into the how can we treat the specific waste with the technology component. And when the product is mature, we also need to have a very mature market to support the use of those materials as well. I want to particularly focus on aggregate for today's presentations because I want to look into the research on the recycled concrete. As you can see in here that the global aggregate production is really high. You can see it's doubled in the last 5 years, and majority of them are actually generating from China with over 37%. You can also see in here, this is a relatively comprehensive table that highlighting different regions in the world, how much did they produce in terms of construction and demolition waste, and also how much they are recovered and the recovery percentage as well. I know that this is relatively small table, but if I can highlight it in here is you can see in the Taiwan region, they have the recycling rate waste is about 91%. Some of the European countries also relatively high. You can see in Denmark with 94%, and Belgium is 86%. That's relatively high. Some of the waste recovery percentage could even be higher than 100%. That means they're recycled and recycled again. That's why you can see that compared to Australian data and also maybe majority of the audience are in China, they're also relatively low, which is only about 62 and 40% recycling rate in here. Looking into the different kind of aggregate productions, you can see that the lighter bar is the total aggregate productions, but you can see that the darker bar, which is the recycled aggregate productions, which is significantly low. That means we are not really able to use the recycled aggregate for adopting majority of our aggregate productions. Even we are using that as a recycled aggregate, we actually, majority of them are still mainly using it for low grade. We are not able to use it for anything basically above the ground. That is something that we will need to look into. A lot of different kind of reasons behind it, but we will need to see why they are only mainly using it for low grade. And that doesn't mean that we cannot use it for better than just the low grade applications. If I also want to share with you in this particular one is the standards. There are different standards around the world. Again, I'm not going to ask you to read all those details, but all I want to highlight it. Different countries, they have their different standards on adopting the recycled aggregates. But however, there's none of them are really allow us to use it for high grade, or very limitedly allow us to use it for high grade. And a majority of them are only limited us for not more than 30% of the aggregate replacement as well. That means we are very limitedly allowing them to use the recycled materials in our standard guideline. And that means also giving us the hesitations in the industry to use this particular product as well, because there are no standards allowed. And bring it into the challenge, I think very clearly you can see that the recycled aggregate is going to have alternative to the virgin material, but they actually need to reduce the environmental impacts of the concrete productions. However, because of the performance are relatively lower compared to virgin aggregate, that's why normally it's about 20 to 30% reduction in strength. That's why also limited to a different applications compared to what concrete is supposed to be able to use as well. There are certain challenges in here that I want to highlight in here is you can see that in this figure, that the first one is the low quality. I think I mentioned that is because of the recycled material. In general, they are with old cement mortar attached when we're crushing it. That's why the performance are relatively lower. That's why it's that is the issues. But doesn't mean that we cannot be solved it. And we have also limited standards, as I highlight in the last slide. There's limited standards and specifications allow the industry to utilize the recycled products. And we also don't have sufficient financial incentives. There's no encouragement for the industry to use this particular recycled products. And sometimes that in certain countries, we may also have the issues of the distance of the C&D waste recycling facilities are a little bit far. That's why they will be a bit hard to use the recycled products compared to the close by near source for the virgin materials. And it is also have a supply and demand issues. Depends on how much we want and how much we can produce, and for specific purpose as well. But I have to say, all in all, probably customer perception is the most difficult one to achieve. A lot of industry are showing interest to use, but the thing is, they may not have confidence to use it because there are limited examples or in the world that allow us to use it confidently. I often also say in different kinds of magazines and interviews saying that the perceptions from the industry is still very limited in here. And there another idea of the recycling aggregate markets. There are some different kind of directions that showing us that we have certain kind of approach that we could be able to look into the market, be able to achieve it better. For example, you can looking into the different kind of taxations, including the taxations in mining in terms of resourcing the virgin materials, and also the taxation on landfills, which is mostly applied in around the world at the moment already. That means we have a high tax to landfills compared to the tax to using the recycled products or the recycling the products. And the third one you can see is the availability and the cost of the recycled and virgin products. So most commonly, that recycled products are significantly cheaper compared to the virgin materials. That is also help us to boost the market in usage. But last one, as I also mentioned in the last slides, there's a misconceptions and also biased again the performance, because industry always thinking about recycled product is something that is generally weaker. That's why it's very hard to pass that perceptions and also the biasness in terms of that adoption as well. There's a few innovations in concrete that in the recent market I also want to highlight in here. You can see that there are a lot of different kind of technologies. 3D printing, I think most of you heard about that, or different kind of approach of using the concrete products, like different kind of mixing design or the healing process. The second one that in here you can see is using smart materials. There's a lot of them are using different kind of products, such as carbon nanotubes or different kind of nanomaterials to put it into the recycled concrete to be able to help improving the performance of that. But that may also gain the other components of whether it can be recycled again as well. And the third one is the sustainability. A lot of us are actually looking into recycled concrete, low carbon concrete. Probably a lot of you also heard about that, and carbon captures and utilization. I mean, how can we really capturing the carbon in the atmosphere and reusing those effectively? And often life cycle assessment is also bringing in life as well. From here is I also want to highlight a little bit more on the low carbon concrete. I don't know how many of you heard about low carbon concrete, because in Australia there's really hot topic at the moment, probably for a few years at the moment now. What is low carbon concrete? Is concrete produced with a lower carbon footprint than traditional concrete. Most likely low carbon concrete, because of the cement component is the highest carbon emissions in the concrete productions. That's why a lot of the low carbon concrete, they are actually looking into reducing the cement consumption. That means they are substituted with cement substitute materials such as fly ash or slag, the most commonly. But we also have different kind of cement substitute materials are generating to help to produce this low carbon concrete. And overall, the idea is the low carbon concrete, it has lower carbon footprints in terms of the life cycle components. That's what we call it as a low carbon concrete. From here on, I actually want to highlight one of the products, one of the inventions that it has been invented probably for the last couple of years in the laboratory. It is in 2022, this particular product was joining a HOSIP accelerator program. From that on, actually making a big difference in terms of the impacts that we can produce in CO₂ concrete. Here you can see CO₂ concrete. We are naming it as a concrete for a sustainable future. You can see I mentioned about low carbon concrete is mainly looking into the cement substitute materials. a lot of us are thinking about what if we could bring low carbon concrete and recycled aggregate together, because low carbon concrete is the cement substitutes, but we didn't recycle the waste component. What if we also recycle we use the virgin material, replace the virgin material to recycled materials, that was recycled aggregate, and that's why we can see this two actually is a very good marriage together. And that also help concrete to reduce embodied carbon and also embrace that circular solution. That means we can actually recycle and recycle again. And we can reduce the emissions and also permanently sequester the carbon emissions as well. And that's why in here, I want to introduce CO₂ concrete to you. It is a new durable high-strength recycled concrete. What exactly it is? CO₂ concrete is a new process to produce the durable and high-strength recycled concrete. How we do it is we inject carbon dioxide into the recycled aggregate, and the main thing is to improve its bondings, and then the rest of the process is the same. And then that's when the aggregate is improved, the recycled concrete performance will also be improved as well. This process has been considered by different kinds of suppliers, but very difficult to implement because there are different kinds of technologies approach that they are not able to go through yet as well. At this stage, it's still no one really be able to adopt it in the market. And you can see this is actually the carbonation chambers that I have in the laboratory. In the middle one is our first stage carbonation chamber. You can see that the size is relatively smaller. It's about 50 centimeters by 50 centimeters by 30 centimeters, which is like just really like a small black box. And you can put only about 50 kilograms of aggregates in. But in 2018, because we have a slabs that need to pour for the universities, which is relatively require larger amount of materials. That's why at that time we actually producing a commercialized scale carbonation chamber. You can see on the left and the right, they are both the same. The right is the actual one that we have in the laboratory. The left one is the sketched one. You can see that the chamber actually is about 1.2 diameters and 1.6 meter height, which is about human height. It's enough to put 1 ton of materials in. How we arrange it is the aggregate is putting it on top. Normally we are with the bulk bag because we can put 1 ton material in. We put in the bulk bag and then they will do the magic in terms of the carbonation inside. Once the carbonation process is done, and then the aggregate will come out at the bottom. Then we lift the whole chamber up using the heavy lifter in the laboratory, and then the materials can go out. And this is how we carbonate the materials. I cannot tell you exactly the process of how we're doing it because it is under confidential agreement. And in the last few years in the laboratory, we have done any kind of test that you can imagine, not only about the aggregate test, but also done the concrete test as well. We have the physical and mechanical properties that we have done, but also some of the durability tests and also the chemical behavior. You may ask me how exactly it is work in terms of the recycled aggregate or the carbonation process. You can see that in the aggregate component, because it is a recycled aggregate, they are not only about with the old virgin aggregate attached, but they also have the cement mortar attached as well. Those are actually the weak components that we are using for the recycled aggregate. That is also the reason that why the strength is reduced because of the old cement mortar. But while we are carbonating the recycled aggregate, the carbon dioxide actually react with the cement mortar that to help us to make it stronger in here. That is how this carbonation process work. You can also see this particular slide is, this is what virgin concrete look like. If we by purely replacing recycled aggregate to virgin aggregate, if it's 100% replacement, the strength down about 30%. But by injecting carbon dioxide in, the strength actually go back up with matching performance with virgin concrete. Not only about the performance increase as well, the cost is also efficient. In a rough data, it is about $300 per cubic meters for a virgin concrete. Because recycled aggregate in general is about half price of the virgin aggregate. That's why the cost will go down, but the strength is also go down in here as well. as by injecting carbon dioxide into the recycled aggregate, the strength go up, although the cost will go up, but overall, we're still about 10% cost reductions in the 100% CO₂ concrete compared to virgin concrete. We have also developed a model. This model is under patent. That's why you can see all data are empty at this stage because I'm not able to share the data with this, but this is protected under a patent as well. What is this particular idea of this model look like is because of the production of concrete, we have different kind of mixed design. If you know how to produce concrete, you need to put different kind of cement, water, sand, and everything in. Every company, they have their own mixed design. If the company can tell this model, what is your input look like? That means what are your mixed design look like? How much you want? You can also put your restrictions in as well. Say, for example, you don't want to use more than 50% of the recycled aggregate. You can put those in as well. Then we'll be able to tell you how strong that concrete will be, what's the behavior of that. I mean, how many MPa the concrete will look like. Or alternatively, a lot of industry will be looking into the other way is, I want to achieve a 35 MPa concrete. You tell me how to do it. That means from output to input. And here I can also do that as well. That means you can put what is the target strength and put certain kind of limitations. Say, for example, you want to reduce the amount of cement or reduce the amount of aggregate. We can also put those in. Then I'll tell you how to do it. That means is the two ways component. Is you can give me an input, I can tell you output. Or you tell me what output you want, I can tell you what inputs required. That's why this particular model is very efficient in terms of the mixed design a component in here. And you can see that this project can able to bring one solution to endless benefits. Not only about helping the circular components, we can turn waste into the valuable materials, but we can also permanently sequester and store the carbon emissions in the concrete. Because of the behavior of the concrete also improved, we actually upcycle the waste and provide the added value products in this particular component. I have a during the hosting program, we were able to produce a commercial video to help explaining how this production process works to the industry. We have produced a 90 seconds video in here. Please let me know if you can't hear it.
The world is in a race to reduce the amount of human-induced carbon being emitted into the atmosphere. One of the biggest emitters of carbon is concrete. After water, concrete is the most widely used substance on the planet. In just the time it took to get to this point of the video, 19,000 bathtubs of concrete have been poured. Traditionally, when a building is demolished, the old concrete is never repurposed, making its way to landfill. What if there was a way of not only recycling the concrete, but also using the concrete as a vehicle to capture and store carbon created during the manufacturing process? Introducing CO₂ Concrete, a revolutionary new durable high-strength carbon capture concrete that uses recycled aggregates in conjunction with low-carbon concrete. These treated recycled aggregates are fed into a chamber where they are injected with CO₂, which not only improves the quality of the aggregate, but also its performance. The CO₂ treated aggregates are then taken to a concrete plant to be used in the final concrete mix. The result is a more sustainable building with a reduced carbon footprint. This is a truly circular economy solution that turns construction waste into recycled materials without compromising performance. CO₂ Concrete.
Okay, this is just a very quick video to highlighting what we have done so far. Sorry. I did move it. Okay, and for this particular program in that 9-month program, we were also targeting 3 main milestones to achieve. One is to determine the viability, just to ensure that whether our business model work, whether we are ensuring the life cycle component work as well. And another one is the demonstration steps. We have poured a few number of steps. I'll also show you a little bit later. And the last one is the communication strategies. That means in terms of different kind of social media, you can also see this PowerPoint is designed in a different way because that is also part of our communication strategies as well. And this particular research has been conducted in the laboratory over the last 10 years now. And as I mentioned, one of our main goals in this project is to produce the commercialization slab, the demonstration slabs. We have done different kinds of slabs in the university environment, but we were really keen to produce the commercial slabs. That's why in October 2022, we managed to pour the first commercial concrete at the Blacktown Animal Rehoming Centers. At the moment, it's still at the Blacktown Rehoming Center as well. And although the program was finished in 2022, but the industry relationship hasn't been finished. We are still want to engage in further with this kind of research. That's why we have a second commercial concrete slabs exactly about 1 year after the first slabs poured at Edmondson Park, North Community in Carbide. And this one, actually, we have increasing the replacement percentage. The first commercial slabs was conducted with 40%, because if you remember me saying that the international standard is roughly about 30%, we want to go over it. That's why the first slabs was with 40%, and this one we were pushing to 50%. And after these slabs, after this second slabs, after the last commercial slabs in New South Wales, we are also managed to do the third one, but it's outside the States. We actually done that in Victoria at Maidstone Train Maintenance Facilities in this year, March. You can see that we have actually a whole lot of new partners compared to the last partners. We are using different kind of suppliers. We are also using different kind of materials as well. But the product is still working perfectly. And if you can see in the left bottom figures that we are also pouring some cylinders to bring it back to Sydney to do some continuously testing. At the moment, we are still conducting the different kind of testing to see the behavior of it with the commercial product. That's why these three slabs are the main thing that we have produced so far. And this particular one that we have also pushed the limit, we are pushing from 40, 50, and this one is a 60% replacement. And what we are aiming is to just further increasing those particular replacement percentage as well. And this particular product was also named as a 100 climate, under the 100 climate conversations under the Powerhouse Museum. It was at that time they were looking into each week to targeting one of the climate leader with their products. And 100 climate conversations is 100 weeks discussion. That means you can see it's actually lasts over 2 years of the product. And this particular one was done in one of the week as well, and has one of the interview is still available online. And the link I think is in the is in here as well. In here, close to the end, I want to highlight that there's a lot of information that I can share with you in the CO₂ Concrete or with these particular inventions, but I can't really share all the details, but you can actually try to, if you're interested, please go to the website. It's the CO₂concrete.com.au. You can see the technologies approach that we're using and different kind of demonstration slabs that we have done. I'm also sharing the different kind of publications that we have in here as well. In here, just a quick summary. I just want to highlight that what are the roadmaps that we have done so far. This particular research was started about 2015 in a very conceptual design. We have joined the top 8 research teams in Australia in 2017 under the Innovise program. At that time, the product probably is still a bit in the early stage. And then after further development, and then 2022, we were under the Holcim Accelerator program. And then we have also done the 3 different kind of slabs, as I share with you in today's presentations. But the next step is we really want to looking into technology transfer or see any other industry that is interested that we can actually partner with them. And while this roadmap, we are also sharing a 3 minutes journey video to just highlighting how our journey look like.
The world is in a race to reduce the amount of human-induced carbon being emitted into the atmosphere. One of the biggest emitters of carbon is concrete after water. Concrete is the most widely used substance on the planet. In fact, every second, 19,000 bathtubs can be filled by the poured concrete globally. Traditionally, when a building is demolished, the old concrete is never repurposed, making its way to landfill. What if there was a way of not only recycling the concrete, but also using the concrete as a vehicle to capture and store carbon created during the manufacturing process? Introducing CO₂ Concrete. A revolutionary new, durable, high-strength carbon capture concrete that uses recycled aggregates in conjunction with low-carbon concrete. These treated recycled aggregates are fed into a chamber where they are injected with CO₂, which not only improves the quality of the aggregate, but also its performance. The CO₂ treated aggregates are then taken to a concrete plant to be used in the final concrete mix. This is a circular economy solution that transforms construction waste into recyclable material without compromising performance. The carbonation process is not publicly available due to confidential agreement. The journey of CO₂ Concrete has been marked by continuous progress and breakthrough innovation. The first successful pour was completed on October 26, 2022, at the Blacktown Animal Rehoming Centre in Sydney. A 27 by 2 metre slab, using 40% carbonated aggregate. The pour was carried out in partnership with Holcim, A.W. Edwards, Bouygues, Sika and Mark McDonald. The second was on October 31, 2023, at Edmondson Park North Commuter Car Park. A 25-metre pathway was poured with 50% carbonated aggregate with support from Holcim, A.W. Edwards, Transport for NSW, Liverpool City Council and Western Sydney University. The third took place on March 12, 2025, at Maidstone Tram Maintenance Facility in Victoria, in collaboration with Heidelberg Materials, Alex Fraser and the Northwestern Program Alliance. This 25-metre pathway reached a 60% replacement rate, our highest yet. Each pour builds momentum, pushing CO₂ Concrete closer to mainstream adoption. Looking ahead, we will continue to promote this product, working closely with government to ensure that the implementation of innovative solutions strengthens industry demand. With collective effort, we believe every step we take brings us closer to building a better and cleaner Australia.
You can also see that there are different partners that is engaged in the project so far as well. Next one. And I just want to share a little bit of my journey from my passion to innovations. Thank you. I'll stop sharing the screen and I'll pass it back to the host.
Well, thank you very much for your outstanding program, as I was astonished by your two fantastic common applications in Australia. That's really awesome. Okay, let's move into the next session and the discussion, free discussing. And I'm honored to invite one of our guests to join our panel. Associate Professor Bo Huang from Hunan University of Science and Technology to join as a guest to discuss further details. So Dr. Bo Huang is a special appointed associate professor and a master supervisor. He is recognized as an outstanding overseas talent. Dr. Huang received his bachelor engineering in civil engineering from the University of Wolverhampton in 2014. His master in engineering project management from the University of Manchester in 2016, and his PhD in engineering from Lancaster University in 2021. His research focused on the enhancement performance of cement-based and composite materials using 2D bio-nanomaterials, which are high-performance concrete, microstructures, and hybridization analysis of green UHPC, and the development of 3D printed recycled concrete. He has led participated in 8 domestic and international research projects. Let's welcome Professor Bo Huang.
Thank you. Hi, Professor Vivian Tan. Thanks for your impressive presentation. Okay, Junbo already introduced me. I already do some research related to the carbon dioxide. and I think your research is very meaningful. And for me, I prepare some question or want to discuss with you for your research progress and how to, from the lab to the really construction. I know it's absolutely hard for everyone. The first one, in my humble opinion, the carbon dioxide concrete improved its performance by injecting the carbon dioxide into recycled aggregate. Could you explain how its research work at microstructure level? Does it involve formation of calcium carbonate or to the strands or like interfacing bonding? Yeah.
Yeah. That is the major components of how this carbonation work, obviously. If you can see one of my slides, I was sharing that because of the recycled aggregate, not only about with the virgin aggregate that is already still in because they're crushed, but they also have the no one like all mortar attached into the recycled aggregate as well. That is the strength reduction that is leading to the recycled aggregate. What this carbonation process work is, the carbon dioxide is targeting for those old cement mortar to react with the chemically react with it. The idea is to with the original cement mortar, which is a calcium hydroxide plus the carbon dioxide that will create calcium carbonates. Calcium carbonate is what concrete wants, and that's why the improvement of that as well. And of course, how we can actually carbonate these products, be able to bring it as solid as we can, as best as we can with the calcium carbonates we want. That is actually the secrets of this particular product, and it's also the under confidential agreement is there as well. A lot of different researchers are trying to use different approach to improve this particular carbonation process. And the aim thing is still trying to improving the generation of the calcium carbonate in here. Jimbo, I think Bo is dropped offline. Oh, I think he's back now.
Oh, sorry, I'm back now. Okay, sorry for that. Okay, yeah. Oh, what a shame. Yeah, thank you. For the second question, I heard you already, do some work for the really construction, like into the road, and I recognize in 2025, you already do some research and construction in Australia. Is the carbon dioxide concrete currently suitable for the use in structural concrete? Because I do some research, but as you mentioned, for the aggregate, the waste aggregate, it's inconsistent the quality. Not all the recycle aggregate standard. Because for my research, I got some recycle aggregate, but after 1 year, I cannot guarantee got exactly, the same stuff. Yeah. How
Yeah.
can you, make sure or to confirm does it suit for the construction structure?
Yeah. I think first is to control the aggregate quality. That's very important, as you mentioned, because of the inconsistencies with the recycled aggregate. That is also not helping us to use the recycled aggregate for the concrete productions at the moment as well. But I have to say, if we control the component well, the recycled concrete is nothing different from virgin concrete. We should be able to use it anywhere we want. Although at the moment it's still limited to low grade, partly due to the confidence level. But I always say that recycled concrete or CO₂ concrete can be used for anywhere concrete needs. I can't see any difference of that. But you may ask me, then how can we ensure the market be able to supply the products that we want to be able to use it? That is the very tough one. I am not, or you are not able to solve these questions alone, because the industry has to change it. There's different way that we could do that. At the moment, I can see that the waste collection is always collected as mixed. We need to collect it as source to be able to help it. I normally work with the certain concrete companies that they also collecting different kind of waste, but their waste are actually very pure concrete waste. Say, for example, Holcim, they are actually having they are concrete suppliers. They actually have, like, as you order in concrete, you wouldn't order exactly 100 cubic meters that you want, you have to offer a little bit, 10%, 15% extra. You must have waste, because otherwise you'll be a disaster when you get there, just a millimeter short. That's why you have to have waste. And that kind of waste that this particular company, they are actually return it back to the company. They actually like with a truck size, like a bean, like a bulk bean, and then they just pour all those waste concrete in. Once they are done, they actually store it in the big pieces, and then they find a way to crush it. Those are actually the pure concrete waste that we need. And that kind of concrete waste that I have been using with the company, because the company also thinking about, okay, we return all those waste concrete. It's very perfect recycled aggregate, but how can we use it? That is also the questions for those companies as well. But I can see that this is a perfect marry with CO₂ concrete, because that what we want, the good consistent recycled aggregate to be able to produce. And that's, I have been working with those in a way. But again, we have to go back with the source, not about this particular company, other company as well. We have to go back with the source of how can we ensure that those can be able to sorting properly, and then they will not be able to mix, and then all helping the inconsistencies in terms of that waste production. Then the next step will have no problem after that.
Yeah, you're right. Yeah, that's great. Wow, that's really meaningful for us, as the earlier researchers doing the research for the carbon dioxide. Because the carbon dioxide emissions for us, my research area is for the cement hydration, degree of hydration. We all know the concrete related product will emit like around 8% of the carbon dioxide in whole world. But for our research still stuck in one place is the biggest challenge for us is doing the research in the lab. It's okay, but how can we translating this type of new product technologies from the laboratory research to the real world construction project? Yeah, did you have any recommendations or idea for us to do that?
Yeah, I can't see the issue in terms of the technical side, because I always say that we mix 1 cubic meter should be the same of mixing 10 cubic meters or 100 cubic meters. I can't see the scales of that we have problem. I think the main problem from the lab to the impacts is about how can the industry be confident in using the product as well. For me, I normally is trying to do some trial labs products with their material first to see whether that particular material work in the labs. But for my perspective is most of the time is quite work on that. And surprisingly, I can share one of the experience in my recent pour. At that time, they don't want to increase the recycle percentage of the aggregate so high, because that is like never happened in the world, and why they have to be doing it, they will hesitate on doing that. And but for me is I want to push the boundaries, and we were giving a commitment of they have also the aggregate and concrete labs as well, and most of the concrete suppliers, and then they actually tested the materials that we are carbonated, and at the end they were actually surprised of how the product worked so well. They were not able to understand why the recycled materials, before they don't do any work, they can't utilize it in the appropriate way. But after we carbonate it, actually the product is so much better. They were surprised with the result as well. To me, I think is the confidence of the industry is still very limited at the moment. Like as I say that, like we're using the waste product, it is very difficult for anyone to understand. And if you are, say, for example, if the cost of 2 buildings is the same cost, one is a perfectly normal buildings, but the other one might be built with all recycled materials, you will be hesitant to living in the recycled material building as well. That is the same perceptions of any kind of recycled materials that we have in the market happening. And but I think is that's also the approach that I'm doing is to just slowly improving the replacement percentage, improving the applications. Hopefully we can gain a bit more confidence from the industry and to further reuse it. But we have to do, like in Australia, we have to do it very slowly and to just really aim to build up the confidence in here. Yeah, that is just the approach that I'm using, but not necessary to be everyone approach.
Okay, that's good. Thank you. Thanks for your explain and the recommendations for us. Yeah. Thank you.
Yeah, Professor Tan, I personally got some question quite relating to the applications. So want your answer. So in China, when we
Sure.
apply recycled concrete or 3D printing concrete, the one of the big issue to be applied is the standard to be accepted or checked. So what do you think of the corresponding standard in your area according to your experience? Yeah.
Yeah. In Australia, recycled material has no standard until now. There's no official Australian standard in the recycled materials. The newest in the recycled concrete component is 2002 under HB 155. It's 2002. It's over 20 years old already. They still didn't even try to update that. That is only a guideline as well. And that's why you can see the standard component of recycled materials is really, really weak. Basically, it's non-existent. And that is the reason that is getting a lot of attention from the academics and also industry. At the moment, Australian Standard has a subcommittee looking into recycled materials, and I'm also part of the subcommittee as well. And we are looking into how different kind of materials be able to develop, might not be a standard as such, could be like a specifications or like a technical specifications at the beginning, but we will be able to move it forward. But the idea is different kind of materials like concrete, plastic, different kind of material. We actually develop under the Australian standards to just guide them how to use it properly. Particularly most of those different kind of old guidelines has been really expired. And that is the approach that we have been doing. But I have to say that this process has been relatively slow as well. It will still need a lot of acceptance in terms of different kinds of parties to push that forward. But I can see that there's a need of it, and the industry want to see that, and academic also want to have those to come out as well. And all of us actually working together to create this kind of standards in the market.
Oh, sure. Thank you so much for your patient and brilliant answer. Okay, let's see. Let's move into the last part. So free discussion. Yeah. So the people who are watching our live streams in our channel, just feel free to share your question in the chat box. And if you like, you can raise your hand and wait for the moderator to invite you. And then we kindly ask all participants to speak English during the discussion. And well, let's see, are there any other further questions interested for this? Okay. Okay. It seems like we are still astonished by your advanced technology to put the carbon dioxide in the concrete. So far we have got the 2,500 people to have watched your presentation today, only in one platform, and we are still counting the other whether there are more people to see your presentation. I think today's activities is a kind of successful and with big social influence. We thank for your attendance, and we really appreciate your outstanding knowledge and application experience in Australia. And I wish you have a happy time in the upcoming international conference. And I think that's the end of today's forum. And are there any questions from our host, JBDE? If not, I think we can just thank you very much for your attendance, and wish all you guys have a good, happy time. And see you next time.
Thank you for having me. Bye.
Goodbye. Bye.